see, what is today? Today is Tuesday, March 5th. And we are still going to continue with equations today. Okay, but today we're going to be looking at some added things with variables on both sides and some unique things that can then happen with equations when that's the case. So today our rules are still the same. We're sticking to the exact same rules that we did last time. So our step one is still, if there are parentheses, I'm totally shorthanding these because we've already done them, we are going to distribute. At this point in time, if you say, I don't know what it means to see parentheses and decide if I should distribute, then you should probably be coming in for some extra practice with plus time. Okay, if there's no parentheses, right, we will skip that step. Our second step is going to be if there are like terms, combine them. But this now comes with an added piece today. Okay, so we've been working on the concept that if we see variables on the same side of the equal sign, we should get them together. But today we're going to open the door where we don't just have some stuff happening on one side of the equal sign, but now we're going to allow for stuff to be happening on both sides of the equal sign. Okay, the process is still the same, we're just going to have to be working on both sides of the equal sign at the same time. Okay, which means we could have something like we saw in the POD. Okay, so we could have something that says 6y minus 8 minus 2y equals 32. Okay, and if we look at this situation, are those variables on the same side of the equal sign, or are they on opposite sides of the equal sign? Same, right? They are on the same side. You're like, oh, I'm not sure what she means, right? My equal sign is right here, so if I draw a line right here, the y's are both on the left-hand side of the equal sign. Okay, if the variables are on the same side of the equal sign, we're sticking to exactly what we did last week, and we are getting them together with the same sign that we see. Right? We see a 6y and a negative 2y. I mean, you can put the y with it. 6 minus 2. It is exactly what we see. 6 minus 2 gives us 4. Right? We can type it into our calculator exactly the way we see it, and that's all that matters. Okay, but we also now want to account for the fact that maybe we'll have something. Whoops, that's not an equal sign. That says 6y minus 8 equals 2y plus 32. Now, there are all types of tricks out there for combining variables when they're on opposite sides of the equal sign. Okay, some of my students always want to move to the left because they always want their variable on the left. Some of my students always want to move the smaller variable because they want to deal with as few amount of negatives as possible. Okay, all of those are fine preferences. I don't know that there's one that is foolproof all the time where I never see a student make a mistake. Okay, so if you are a student who says, I really don't like when my equations are set up with my variable on the right-hand side, then Sure. Move your y over here to the left. Okay, if you say, I don't care which way I move, I'm going to move the smaller one, that's fine. That's more of a personal preference. I don't want to force you into a box that you're not comfortable with. Okay. But if we look at this, right, do we agree that we have a y here and we have a y here? But now when I look at my equal sign, this y is to the right and this y is to the left. Those y's have an equal sign in between them. They are on opposite sides of the equal sign. So to get those y's together, we are going to have to use the opposite sign to get them together. Okay, so we have, let's see, let me pick a new color. We have a 6y here and a 2y here. Okay, and if we look at the sign that's in between them, we have to decide, right? Is this 2y positive or negative? Positive. Positive. Right, so if we look at it the way it is, it says 6y plus 2y. But because they are on opposite sides of the equal sign, we need to get them together with the opposite sign. Right, so the opposite of a positive 2y is a negative 2y. Okay, I personally choose to always write it underneath the two places with the y's. Some of my students prefer to just circle where they see the y's and to use the opposite sign. Again, I'm fine on that as long as it's working for you correctly. Okay, so 6y minus 2y, again, you can still just use your calculator, right? 6 minus 2. And we would be able to solve from there. Once we get past that point, the remainder of the steps are going to be the same today. So we're still going to have a step 3 that says deal with the large fraction if there is one. Step 4 is still going to be to undo addition and subtraction. Step 5 is still going to be to undo multiplication and division. So if you're a person who prefers steps and you want to know what do I do first, what do I do second, what do I do third, right, there are your steps. If you're a person who says, I don't want to follow steps, I want to know the concept and the understanding of it, right, we're doing order of operations backwards. I think one of the largest challenges for my students with equations in this format is to get over the mental hurdle that because a problem has more pieces to write down doesn't necessarily mean that it is a more difficult problem to do. Okay, I frequently get students who, I watch them, right? They see a problem like this and they go, that's long, turn the page. I can't do that, that's too hard, there's too many parts. But again, if you break it down into one step at a time, this really isn't any more complex than what we have been doing. We know how to combine like terms, we know how to use inverse operations, so we just need to look a step at a time. So step 1 says, if there are parentheses. Well, do we see any parentheses? Nope, right? So check, that step's done. Step 2 says if there are like terms. Do we see any like terms? Yes. Okay, there is not a rule of what you have to do first to combine like terms. My students prefer to simplify one side and then deal with opposite sides. But that doesn't mean it's a hard written rule either. So let's say we look over here on this side of the equal sign. Are there like terms to combine? Yes. So do we agree we can combine 5x and a negative 3x? Agreed? Yes. Are these on the same side or opposite sides? So same side, we're going to get them together with the same sign. So what is 5x minus 3x? 2x. So we have 2x plus 7 equals a 3x plus 12. Any other like terms we have to get together? Right, these? Are these on the same side of the equal sign, or are they on opposite sides of the equal sign? Opposite. Anybody have a preference as to which one they would prefer to move? Diego, can I pick on you for 1 second? And not a bad way? Diego, if you got to move one of these, I think, from what I've seen, I could be wrong, would you prefer to move the 3x over here so that your variable's on the left? Yeah. Right? Diego would prefer his variable to be on the left. Who cares if it's positive or negative? I can use a calculator to check that math. I want my variable on the left. Okay? Preston, I think you're going to say the other answer, right?
Either or doesn't matter.
Right, but that maybe you would prefer the positive. That choice is sort of up to you. There isn't necessarily a given perfect response that you have to pick. Okay, but let's just go this way so our variable's on the left, because I know there are several of you who prefer that. So since they're on opposite sides, we have to use the opposite sign. So is this 3x positive or negative right now? Positive. What's the opposite of a positive? A negative. So what is 2x minus 3x? Everything else is just coming straight down. Step 3 says to deal with large fractions. We don't have any. Step 4 says to undo addition or subtraction. So how do we undo adding 7? How do we undo this negative 1? Divide. So we'll get x equals negative 5. Right, do we see how that sort of just fits right in with that step we already had? We just have to make sure we're getting all of them together in that second step. All of those variables together. How about this example? No. Three times the quantity of 2x minus 7 equals 4x plus 9 minus x plus 3x minus 1. This is not hard. This is long. It might take you a couple more minutes to do it. It has more steps, but it's not hard. Okay, so step 1. Do we see parentheses? Sure do. So what do we need to do? Distribute. 3 times 2x is 6x. 3 times negative 7 is negative 21. Okay, your quizzes have been looking good. Distributing has been looking good. I know we can do that. We have some like terms to combine over here for our step 2. So here's one, here's another, here's another. We just have 3 of them. That's okay. Are these variables on the same side of the equal sign or opposites? So same side, we're going to use the same sign. So what is 4x minus x? 3x, because what number is really here? 1. So 4x minus x is 3x. And then what's 3x plus 3x? 6x. So 6x. Plus 8. Okay, so now we have 6x's on both sides. Which one do we want to move? 6x or 6x? Not really going to matter, right? Okay, are these 6x's on the same side or opposite sides? Opposite. How do we move a positive 6x? Now you're all starting to look at me funny. Mrs. McKinney, what are you doing here? Well, what is 6x minus 6x? 0. Okay, one of my students' favorite things to do is to decide that I must have done something wrong, or they have done something wrong, and there is no way that that x can go away. And so even though 6x minus 6x is 0x, they better still put an x in there because I don't know. 6 minus 6 is 0. The x is gone. It's gone. It is nothing. It's 0. It's gone. Don't make one magically appear. We are not magicians in this class. Okay, we are left with negative 21 equals 8. That's it. There is no variable. There is nothing less to solve for. Okay, so we have a decision to make. Is this a true statement? Does negative 21 equal 8? Or is this a false statement? False, right? Negative 21 does not equal 8. Right? I would love to spend $21 and then someone go, oh, here's $8. Yay for you spending 21, here's 8. That's not going to happen.